Okay, November 2022, paper 2, variant 2. Yeah. Question 1. Again, you have a micrometer screw gauge, which has been removed from the syllabus, but basically, if you want to find the volume of a liquid, you need a measuring cylinder, diameter of thin wire. Yes, it is a micrometer screw gauge, but it has been removed from the syllabus. Question 2. Diagram shows a speed time graph for 4 bodies moving for 6 seconds. Which body has traveled the least distance? Least distance. So basically, you need to find the area under the graph. Area under the graph. So basically, first area is what? Half times base times height. Half times 6 times 8, which is 24 meters. Okay, second area, you have actually two areas. This one and this one. So half times, let's say 4 times 8. Okay, this is 16, and then half times 2, okay, times 4, which is 4. So the total area is 20. Total distance traveled is 20 meters. The total area in this question is 8 times 4, half time, it's not half, 8 times 4, which is a rectangle, 8 times 6, I'm sorry, which is 48 meters, and the last area is this rectangle, the same rectangle, minus this smaller rectangle, which is 2 times 4. So basically, you subtract 48 minus 2 times 4, which is 8. 40. So the least area, the least distance traveled would be, it would be B. Yes, least distance traveled. Question 3. Which statement describes the relationship between mass and weight? Mass is the effect of the gravitational field, is the effect of the magnetic field. Weight is the effect of the gravitational field on the mass. Yes, definitely. Weight equals mg. Diagram shows 4 pieces of laboratory apparatus. Which pieces of apparatus are used to find the density of liquid? Do I need a stopwatch for the density? No. So basically, you need the balance and the measuring cylinder. Okay. Do you need the ruler? Do I need the ruler? No, I do not need the ruler to find the density of a liquid. Balance and the measuring cylinder. Question 5. Okay. The rule rests steadily on the supports. Which row is correct? It's resting. It is resting. What is the total moment about M and what is the total moment about N? It's a really nice question. Question 5. What is the total moment? Is there a clockwise moment? Is there an anti-clockwise moment? No, there are none. Why? Because it's resting. It's in equilibrium. So the total moment is zero on both ends. Zero resultant moment. This is what we call zero resultant moment. Okay, question 6. In which labeled direction is the force? Definitely, it's the centripetal force is always towards the center of the rotation. It is the Question 7. A trolley of mass 4 kilograms is traveling with a velocity of 4 meters as seen. Another one is traveling with a velocity of 2 meters. After collision, the velocity of the 4 kilograms is reduced to 3 meters per second. What is the velocity of the 2 kilograms? So it's quite obviously going to increase. The velocity will increase. Can I use the equation? Yes. What is the equation? m1u1 plus m2u2 is equal to m1v1 plus m2v2. We have everything. The only missing number would be v2. m1 is 4 times 4 plus 2 times 2 equals 4 times 3 plus 2 times v2. Okay, 16 plus 4 is 20. And then equals 12 plus 2v2. A lot of you would do this fatal mistake of adding 12 and 2. You can never add 12 and 2. Please do not do this very silly mistake, if I might say. Just divide. minus and a subtract. So subtracting this would be 8 equals 2v2 divided by 2. This would give you an answer of 4 meters per second. An object falls towards the Earth's surface. What happens to the gravitational potential energy and to the kinetic energy of the object as it's falling downwards? As it's falling downwards, the gravitational potential energy decreases. Kinetic energy, yes, it increases. Excellent. Yeah. Question 9. Which power does the boy develop? Okay. Boy takes 0.6 seconds to lift a book of mass 0.6 kilograms to the top of a desk and place it on a shelf. From the top of the desk and place it on a shelf, which is 0. Top of the desk is 0.8 meters. The shelf is 1.7 meters above the ground. The gravitational field strength is 10. Okay. Okay, it's not bad. What is the power? Power equals energy over time or work done over time or energy over time equals energy. Okay, energy over time. So basically the energy would be the gravitational potential energy. Gravitational potential over time. What is the gravitational potential? So it's mgh. mgh over the time taken. mgh is 0.6 kilograms times the g 10. Okay, let's use 10 times the h, the height. Is it 1.7? Is the height 1.7? No, the height isn't 1.7. The height would be the difference between them. The height would be this height, which is 0.9. 1.7 basically. 1.7 minus 0.8 is 0.9. Divided by the time taken, which is 0.6. So the power would be 9 watts. Power would be 9 watts. Question 10. Mass is lifted from rest on the ground to Y. P is the increase in gravitational potential energy. Q is the increase in kinetic energy. Which expression is equal to the mechanical work done on the mass? Mechanical work done. What is the mechanical work done? It is the total energy. Okay, the total energy added to the object. As the object is moving upwards, it gains kinetic energy and gravitational potential energy, not just gravitational potential energy. He didn't say that it stopped at Y. He didn't say that it stopped at Y. It's still moving. So it still has kinetic energy and gravitational potential energy. The diagram shows a tank containing seawater. The density is 1200. What is the pressure at point P relative to the atmospheric pressure? What is the pressure at P? Okay, so you have 8 meters and then you have 60 centimeters. So basically, pressure equals rho GH. What is rho? The density 1020. G should be 9.8. I know it should be 9.8. Let's use 10 for now. It should be 9.8, but I will use 10 for now. Okay, and then the height or the depth below the surface. The depth below the surface is what? Is it 8? No, it's not 8. It's 8 minus 0.6. This is 0.6. So the height below the surface is 7.4. Okay, it is 7.4. Can I find 1020 times 10 times 7.4, which is 75,480, or just around 75,000 pascals? Okay. Question 12. Which graph shows how the pressure of the gas changes during this process? Pressure of a fixed mass in the cylinder is measured. The volume of the gas in the cylinder is decreased as you decrease the volume, as you compress the cylinder, The temperature does not change. It doesn't change. How? Which graph shows how the pressure changes during the process as you decrease the volume? As you decrease, what happens to the pressure? It increases. It increases. So should it be B? No, it shouldn't be B. Why? Because the pressure wasn't zero. The pressure initially wasn't zero. The pressure was let's say the atmospheric pressure, 100,000 pascals. As you decrease the volume, the pressure increases above 100,000 pascals, not above zero. Not above zero. Okay, you hang the clothes outside. Why? What are the best conditions for the clothes to dry most quickly? Wind speed. Yes, we need wind. And do I need a high temperature? Yes, definitely. During the summer, it would be best. Which change in the design of a liquid? Oh, this has been removed. Thermometers have been removed. Okay, again, specific latent heat has been removed. So question 15 is cancelled. Which piece of equipment is designed to produce a type of electromagnetic wave? Electromagnet? That's a magnetic field. No. Electric motor? No. It produces sound waves if you want. Okay. It produces kinetic energy, but no electromagnetic waves. Electric generator, it produces electricity, electrical energy, whatever. Okay, you can say but this electrical energy has a magnetic field around it, but again, no electromagnetic waves. Electric fire, yes, it does produce light waves and infrared radiation. Question 17. A sound wave travels from air into water. What happens to frequency and what happens to the wavelength? The frequency of any wave always remains the same. Frequency of one wave. I produced a wave. Whenever you produce a wave, the frequency of this wave doesn't change. But the wavelength and the speed of this wave can change due to the medium in which this wave is traveling. So the frequency is the same, but the wavelength doesn't increase or decrease as it moves from air into water. A sound wave is a mechanical wave, which actually requires medium. The better, the more the better. So actually the wavelength increases. It moves at a higher speed. Which name is given to this effect? Diffraction. Okay, that's easy. What is the refractive index of the material? So you have air and material, you have light. So N equals sine air over sine medium. Sine air, sine 40. Is that right? Does that sound right? It sounds right, but it's wrong. Why? Because the angle of incidence is not 40, it's actually 50. Angle of incidence is actually 50. So sine 50 over sine 27. Sine 50 over sine 27. This would be C, 1.7. Hmm. Okay, at which labeled position is the image of the object formed? So if this is the object, then this is the image, B. I hope all the questions are that easy. The angle between an incident ray and the surface is 70. What is the angle of incidence? The angle between an incident ray and the surface of a plane mirror reflecting the ray is 70 degrees. What is the angle of incidence? You'd be tempted to say 70, wouldn't you? Okay, most of you would just say 70. Well, the angle of incidence is 70, so the angle of reflection is 70, which is wrong. Why? Because this is not the angle of incidence. This is not the angle of incidence. If you want to think about it, so this is the mirror. Let's draw the mirror. Okay, this is the mirror. He said the angle between so you have the ray which is moving towards the mirror. Okay, you have the ray which is moving towards the mirror. What is the angle of incidence? The angle between the incident ray and the surface of the plane mirror. So this angle is 70. Where is the normal? This is the normal line. What is the actual angle of incidence? It's 20. What is the actual angle of incidence? It is 20. So the angle of reflection is also 20 degrees. This is not the angle of incidence. This is the angle with the boundary, the angle with the surface. Question 22. Diagram shows air molecules in part of a sound wave at a particular time. Which statement is not correct? Earlier there was a compression, later there will be a rarefaction. So this is a sound wave which is moving from left to right, or we know it's parallel to the energy motion. Sound waves uh, consists of compressions and rarefactions. So later in time there will be a rarefaction. Yes. Earlier there was a compression. Yes. So these are right answers. We want the wrong answer. This part of the wave is traveling horizontally across the page or traveling towards the top of the page. Definitely this is wrong. It's traveling horizontally, left and right. An object is reflected in a plane mirror. Which description of the image is correct? Plane mirror, same size, and virtual. We have virtual images in the mirror. A 100-meter race is started by a fire gun. When does the finishing judge see the smoke? And when does he hear the bang? He sees the smoke almost immediately. Why? Because the smoke or the light travels at the speed of light, which is 3 times 10 to the power of 8. So he sees the smoke almost immediately. He hears the bang after around 0.3 seconds, which is roughly the time it takes for the sound to travel 100 meters. Which row shows the direction of the forces exerted on X and Y by the magnet? Okay, this is a nice question. X and Y. Are they attracted? Are they repelled? Are they what? They are definitely attracted towards each other. So X is pulled in this way and Y is pulled to this way. So it is B. X is pulled to the right and Y is pulled to the left. They are attract opposite poles. Question 26. What is the resistance of the lamp? The current in the lamp is 0.5 amperes. The variable resistor is adjusted until the potential difference across the lamp is 6 volts. 6 volts, and you have the current. What is the resistance? R equals V over I, so 6 over 0.5 is 12 ohms. Which equation gives the current in the resistor? I equals R Q. If you have the charge and you have the time, so basically I equals QT or Q over T. Is it QT or Q over T? So I know that sometimes you can mix them up. Sometimes you can mix them up. It's Q equals IT or I equals Q over T. Please do not mix them up. Okay? It's either you say Q equals IT or I equals Q over T. Plastic rod is rubbed with a dry woolen cloth. The rod becomes positively charged. The rod, so electrons move from the rod to the cloth. Positively charged from the rod to the cloth. Definitely no protons are moving. Voltage for a filament lamp. Filament lamp. What happens to voltage? What happens to resistance? Basically, the resistance increases. Why? Because the temperature increases. Resistance increases. And we said before that as the resistance increases, the voltage increases. So it will curve towards the voltage axis. Towards the voltage axis. B is not a filament lamp. B is a ohmic resistor. It's a fixed resistor. A fixed resistor. Question 30. Which potential divider makes the potential difference across Y increase when the light intensity increases? Think about it slowly. Think about it slowly. You want what should happen? You want the potential difference across Y, whatever Y. You want the potential. You want the voltage to increase in Y when the light intensity increases. So basically, you want an LDR, a light dependent resistor. Okay, I want a light dependent resistor. So I'll cancel out C and D because these are thermistors. Okay. You want the voltage in Y to increase when the light intensity increases. If the light increases, what happens? The resistance decreases and the voltage decreases. So we need the LDR to be at position X. Why? Because as the light increases, the resistance decreases and the voltage decreases. When the voltage decreases at X, then the voltage will increase at Y, or the potential difference will increase at Y. Need to think about it this way. Okay? Diagram 1 is a circuit diagram showing an AC power supply connected to four diodes, and a resistor. Diagram 2 shows the output voltage of the power supply. Diagram 2 shows the output. Which graph correctly shows the voltage time curve across resistor R? Across resistor R. Okay, this is a really nice question. Again, you have some diodes. Okay, you have some diodes connected to this resistor. Can I draw the current passing through the resistor? Okay, if I have the positive end and the negative end, if it's positive from this side, so it will move from this point, passing through the diode and then passing through the resistor. Okay, passing through the resistor. If you have the positive end, it will pass through the diode. Can it go downwards? No, it has to move through the resistor and then back to the back to the power supply. Okay, good. So you have a positive end. It's moving. Let's say this is a positive end. But what happens if the current is switched? So this is the negative end. This is the positive end. Okay, let's draw an arrow. Let me draw an arrow. First of all, if it was the red current, okay, it would have moved in this direction. What happens if it moves in the other direction? So this is the positive end. It will move in this direction. At this point, it has to move upwards through this diode and then through this resistor in this direction again. In this direction again. And then passing through, okay, and going back all the way to the and then going back all the way to the power source. So if you think about R, that's the question, okay? If you think about R, the current in both cases, in both ends of the cycle, if you might say, are passing through R in the same direction. They are passing through R in the same direction in both ends. Let's say it's moving downwards. It was moving downwards. So it's always to R, huh? If you want to say to R, it's always positive or it's always negative. Basically, it's moving the same direction for R. For R, it is moving in the same direction. So if I check out A, A is wrong. Could it be C or D? C is both are negative and D both are positive. Well, they could be right, but they are wrong. Why? Because the voltage or the current hasn't stopped. It passed through R in both cases. It did, in fact, pass through R in both cases, through C and through D. Okay, so that's why C and D are wrong. Okay, it should be B. It should be B. Why? Because it's passing through R and it's passing through R in the same direction. And it's passing through R in the same direction. So it's B. C, okay, C would have been simply if you just add one diode in one direction. For example, if you had this power source with one diode, for example, this is the resistor, okay, this would have been C. Okay, D would have been, for example, if you put the diode in the opposite direction or whatever, it would have been C or D. But since the current is passing through the resistor in both directions, that's why it is, oh, the correct answer would be, it would be B. Okay. Which is the fuse? Definitely it is D. Logic gates have been removed. 33 is cancelled. 34. Okay, a current is now switched on in the solenoid. Which diagram shows possible new directions of the compass needles? Okay. Can I cancel out two very wrong answers? Yes, A and B are definitely wrong. What about C or D? Should it be C or should it be D? You can cancel out C very quickly. Why can I cancel out C very quickly? Because you cannot have this one pointing to the left and this one pointing to the right. They both have to point in the same direction, okay? For example, both of these are pointing to the right and both of these are pointing to the left. This is the right answer. Okay. Transformers are used in the transmission of electrical power to houses. Which type of transformer is used at the power station prior to the connection to the power lines, and which type is used prior to the delivery to the houses? Right after the power stations, for example, you have a generator, you have whatever station that is producing electricity. Right after the power station, you need a step-up transformer. Why? Because we said when you increase the voltage, you can decrease the current, and then you can decrease the power losses and whatnot. So you need a step-up transformer right after the power station. What about right before the houses? You need a step-down transformer because if you have very high voltages going into the houses, we would all be electrocuted. It is C. Question 36. What are the names of 1 and 2? One is a brush and two is a slip ring, or is it a split ring commutator? Huh. Is it a slip ring or a split ring? Let's check it out. This is an AC generator. AC generators have slip rings. Split rings are in DC motors. Okay. A thin metal foil is placed in a vacuum. Alpha particles are fired at the thin foil. Most go straight through. A very small portion, a very small proportion of the alpha particles are deflected through large angles. What does this provide evidence for? Hmm. Some of them deflect. Some of them deflect. Alpha particles are very small. Well, we know that they are very small, but this doesn't. This is not the conclusion. There are negative electrons in each atom. Negative electrons in each. This is definitely wrong. There is a tiny nucleus in each atom. There is, yes. There are neutrons in each atom. No, this is not the answer. Oh, actually, we didn't come up with this conclusion um, from this experiment. This is wrong. Alpha particles, are they very small? Yes, they are very small, but this is not the answer. The answer is actually C. There is a tiny nucleus in each atom in which the alpha particles hit and went back. Okay, they hit the nucleus, which was very small, and they went back at very large angles. Thorium is represented by 230 and 90. It emits alpha particles. Which nuclide is produced by this decay? Is represented by the symbol. This isotope is radioactive and decays to radium. Okay, you give off radium, which is Ra, and by emitting alpha particles. By emitting alpha. Alpha is what? Alpha is 4 and 2. Alpha is 4 and 2. So basically, subtract 4, 226, subtract 2. Okay, so it would be A. Okay, the diagram shows a piece of apparatus used to determine the nature of emissions from radioactive source. The absorbers can be raised out of or lowered into the path of the radiation from the source detector. The table gives a set of results for the particular radioactive source. You have none, 350 counts per second. If you add a sheet of paper, it remains 350. Do you have any alpha particles? No, we don't have any alpha particles. When you add the aluminum, do you have any beta particles? Yes, we do have beta particles. When you add the lead, do you have any gamma? Yes, we do have gamma. So the only particles, the only radiation given off is beta and gamma. Question 40. What is measured? What is the measured count rate after a time of one half-life? After a time of one half. What is Y? That's a question. That's a really important question. What is Y? Y is the background radiation. Y is the background radiation. So basically, to find the count rate after a time of one half-life, after a time of just one half-life, background radiation X, this is the total radiation. This is the total radiation. Can I find one half-life? Yes. For this question, okay, this is actually a rather new question, or a rather new way of thinking of how to answer this question. Usually we say what? Usually we say you take the initial time and then divide by 2, which would give you the initial count rate divided by 2, which would give you the half-life. Okay, but if you have background radiation, I usually say what? I usually say minus, divide, and then plus. Minus, divide, and plus. We don't have all of these answers, but the short answer would be to add the background radiation and divide by 2. would be just to simply add the background radiation and divide by 2. So, for example, let me solve it very quickly. If it was 530, okay, if it was 530, what I usually said was that 530 minus 30. Let's say that that is the background radiation, so it's 500. 500 divided by 2 is 250, and then you add 250 plus 30, which is 280. For this answer, all you need to do is 530 plus 30, which is 560. If you divide it by 2, it would be 280 again. So 280 is how you can find the background, is how you can find the half-life. Okay? Okay.